Welcome and good morning for Python for statistics. Today we will see the continuation part of the previous video, how to calculate the effect size for the one sample t test. To do that in Python, I will first start the Colab notebook, colab.research.google.com. Then I will click on new notebook. Once the notebook is open, I can give it a name. I can call it effect size, okay, and t test. Then connect it, and I have to upload here the data set, which is GSS2012.csv. So I will click here and upload the data set. Once the data set is uploaded, I can continue with my programming. So I will write the program for loading the data. So here I am storing my data in the variable name of the file is GSS2012a.csv. Further, I will take one variable which is scale. Scale means numeric, so that I will take from my data set that is present in the column age. To remind you, scale variables means variables that contain numeric values. I will take precaution to drop any missing values. Further, I will have to pre-process the data so that any non-numeric values are removed. So for that, we take scale where replace the non-numeric data. The non-numeric data is 89 or older. This statement is present in the data, so I will replace that. Once that is replaced, I will convert the data set to numeric form by pandas to numeric. So this will ensure that I only have scale values or numeric values in my data. Once that is done, I can apply the t-test. So that already we had done. We will need to calculate the mean and standard deviation. So mean is, I will calculate it using the function mean, and standard deviation I will calculate using the function scaleware dot std. So these are the inbuilt functions already present in my Python library. Further, to apply, so I am assuming that the t-test you have already done, so I will not reapply the t-test. I will simply calculate my effect size. So effect size is, once we identify that the null hypothesis is rejected, that means our alternate hypothesis, which says that the mean of the population is different from the hypothetical mean. So we know that it is different from the hypothetical mean, but we don't know how different. What is the magnitude of this difference? Is it a small difference, medium difference, large difference? So to do that, we can calculate the effect size known as Cohen d. To calculate this, we can apply first the mean of sample minus mean of the population. This is the hypothetical mean, and divided by the standard deviation. So this hypothetical mean is what we assume. I am assuming it as 80, because in my previous video we had assumed the hypothetical mean to be 80. Once that is done, I can store this in some temporary variable, and from that I can calculate the Cohen d by multiplying it with 2 to the power 0.5. That means multiplying it with the square root of 2. Since effect size is absolute value, I will use the absolute function here. Further, I have to compare and interpret the Cohen d. So if the Cohen d is less than 0.2, then I will print negligible difference, and we will go on further. If it is greater than 0.2, so else if it is greater than 0.2 but less than 0.5, then the difference is small. If it is greater than 0.5 but less than 0.8, the difference is medium, and otherwise the difference is large. So this interpretation you can get from statistical power analysis by Cohen. Once we can execute this to see if there are any errors. Okay, there is one error, that this has to be saved in the scale variable. Once it is complete, I will get the interpretation that population difference is large from the hypothetical population. This is the way we can implement our effect size for one sample t-test known as Cohen d. So that was it in this video. You can implement this and test whether you are getting the same results. Remember that effect size is only useful if the p-value is less than 0.05. Otherwise it is meaningless to calculate the effect size. That's it. Thank you for watching, and see you again in the next video.